Hello and welcome you all in our next video where we will discuss today the sum of n terms of an AP. So in our previous classes we have derived the formula of calculating nth term of an AP if first term and common difference is given. Okay, so if we know the first term and common difference D, we can construct whole AP. Okay, so assume we have AP whose first term, that is A1 is A, and the common difference of this AP CD is D. Okay, suppose this AP have n number of terms and the last term, that is AN term, AN is L. Okay, so we can construct whole AP. So first term is A and the next term will be A plus D and next term to it will be A plus 2D. And in this pattern number will come, and the last term here is an and that is L, so last term will be L. Okay, so just preceding number to L, last term nth term, it will be L minus D. Whenever we will move in this direction, we just add common difference to preceding term to get next term, and whenever we have last term and we want to come this direction, so we have to subtract common difference D. Okay, so this is the little different difference. So suppose we want to calculate the sum of first term to n term, all numbers coming in between first term and nth term. So we want to calculate the sum. Okay, suppose this sum is equal to Sn. N denotes number of terms, sum of n terms of an AP. So suppose we want to add these terms, so we have to add plus sign in between, first term plus second term plus third term and plus fourth term dot 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 plus n minus 1 term plus nth term, and this sum is equal to Sn. Okay, now the sum will remain Sn if we add these terms and or we just rearrange this sequence and just write nth term first and n minus 1 term, then all their terms, and at last we write these terms A plus D and A plus A. Okay, so I have just written this term here and this term here, and next to preceding to it terms here, and all the sequence we have just opposites, we have just written opposite. Okay, so now I want to add these terms. Suppose this is equation 1 and this is equation 2. In equation 2, I have not added any extra terms or just subtracted any extra term. The numbers of terms here are n, and the number of terms are here are n. First n terms of an AP. So this sum will always remain constant. And now we want to add. It will be L minus D here. Okay. Now we want to add these two equations, so Sn and Sn will make 2Sn. A plus L will make A plus L plus A plus D and L minus D. D plus D and minus D will get cancelled and we will get A plus L. In the third term, here A plus 2D, here it will be L minus 2D, L minus 2D. So, if we add these two terms, this term and this term, minus 2D and plus 2D will get cancelled out and we will get A plus L. So, here it will be A plus L. In this pattern, A plus L, A plus L, A plus L will come, and here L minus D, A plus D, it will be A plus L, minus D and plus D will get cancelled, and here plus L and plus A, we will get A plus L. So total n number of A plus L we are getting from adding these two equations, equation 1 and equation 2. A plus L, these types of A plus L are n times, so total A plus L are n times. So if we add any number n times, that is we are multiplying that number with n. Okay, so this sum will become n into A plus L. and this is equal to 2Sn. We want to calculate Sn, not 2Sn. So from here we can say Sn will be equal to n by 2 a plus l. So this is the formula of sum of n terms of an AP whose first term is a and last term is l, and the number of terms are n. If first term and nth term and number of terms are given and we want to calculate the sum of n terms, so we will use this formula Sn equal to n by 2 a plus l. And if l is not given, d is given, so we will use the formula. So in our previous class I have told last term or nth term formula. So it was like an equal to l, and that is equal to a plus n minus 1 into d. So if l is not given, d is given, and a is given, and n is given, so we will put this value a plus n minus 1 into d in this formula in place of l. So we will get Sn equal to n by 2 into a plus, put value of l this here, so it will become a plus n minus 1 into d. Now it will become Sn equal to n by 2, this a and a will make 2a plus n minus 1 into d. So this is another formula of sum of n terms whose first term is a, common difference is d, and total number of terms are n. So we will use this formula whenever we have value of a, value of d, and value of n. And if we have the value of a and n and the last term or nth term l, so we will use this formula. Okay, so from here we got two formula of sum of n terms of an AP, and first one is Sn equal to n by 2, and second is Sn equal to n by 2 2a plus n minus 1 into d. Okay, so next we will see some examples based on this formula. Suppose we want to add very common numbers, first 100 natural numbers, and we want to calculate what value we will get. Okay, so suppose we want to add 1 plus 2 plus 3 plus 4 plus 5 up to last term is 100. Okay, and we want to calculate the value, the sum we will get after adding these numbers. So if we try to add these numbers 1 plus 2 and then add this 3 and then 4, so it will take more time. Here we have calculated, simply we have calculated our formula for AP. First of all, just check this sequence whether it is AP or not. So I am just trying to check this sequence. So if we take difference between first two consecutive terms, so here the difference between second term and first term, a2 minus a1 is 2 minus 1, that is 1, and the difference between third term and second term, a3 minus a2, so it will be 3 minus 2, that is 1. And if you want to check the difference between fifth term and fourth term, so it will be a5 minus a4, so it will be 5 minus 4 equal to 1. So we can say the difference between any two consecutive terms is constant, and that is 1. So here the common difference is 1 and it is constant for whole sequence. So this sequence is making an AP, and now we want to calculate the sum of these 100 terms. So simply we have a here, first term a is equal to 1, and we have number of terms here. How many numbers of terms here? 1 to 100. We have 100 terms. Okay, so n is 100, and if we want to whether you use the formula a plus l, n by 2 into a plus l, or you use n by 2 2a plus n minus 1 into d. So here we have simply common difference, CD is equal to, or d is equal to 2 minus 1, that is 1. Okay, and we have last term L equal to 100. So if we want to calculate the sum of these 100 terms as 100, so we will use, whether you use the formula n by 2 a plus L, or you use the formula n by 2 2a plus n minus 1 into d. Okay, so using this formula will be easier for this problem. So we are going to put the value of a and L here. So number of terms are 100, so I put in place of n 100, and 100 by 2 a plus L, here a is 1 and L is 100, so it will be 1 plus 100. This will become 50 into 101, and this will become 5050. So this is the answer. When we add first 100 natural numbers, so we'll get answer 5050. You can also put the values of these terms here, n 100 and by 2 into 2a, 2 into 1 plus n. Number of terms are 100 here, so 100 minus 1 into d is 1, so we'll 100 minus 1. Solve this, so it will be 50 into 2 minus 1, that is 1. 100 plus 1 is equal to 101. So from this formula we will also get 5050, that is 5050 our answer. Okay, so first of all check the sequence whether it is AP or GP, and then apply the formula of Sn and put the values of known terms here. You will get answer. Like what we did in case of GP. If in GP, if the product of numbers is given and we want to select 3 numbers or 4 numbers or 5 numbers, so I have told here, so in what pattern will take the numbers. And in case of AP, if the sum of, if in the problem, if the sum of numbers is given and we want to select, we want to take 3 numbers in AP. Okay, first we want to take 3 numbers. We want to take 3 numbers, so we will select numbers a plus d or a minus d, a and a plus d. Okay, so if the sum of 3 numbers in the problem, if the sum of 3 numbers, consecutive numbers is given and we want to calculate 3 numbers, so for our convenience we will take numbers as a minus d, a and a plus d. Okay, so if sum of 4 numbers is given and we want to take 4 numbers, so for our convenience we will take numbers as a minus 3d, a minus d, a plus d and a plus 3d. Okay, and if the sum of 5 numbers is given, and we want to select 5 numbers or we want to choose 5 numbers, so for our convenience we will choose numbers as a minus 2d, a minus d, a plus d and a plus 2d. 1 2 3 4 5. Okay, so this is a concept where you will get the questions, sum of 3 numbers or sum of 4 numbers is given and another condition is given, and we want to calculate the numbers, whole 3 numbers or whole 5 numbers, so we will use this technique, or we will select numbers in this pattern. Okay, so here we have a problem. If the sum of first 14 terms of an AP is 1050 and its first term is 10, find 20th term. Okay, so in this problem we have already given our first term and we denote first term with a, so that is the value of a is 10, and the sum of first 14th term, that is S14 is given. S14 is equal to 1050. And we want to calculate 20th term. To calculate 20th term or any term, we need 2 values, a plus n minus 1 into d. In our an formula, general term formula, an equal to a plus n minus 1 d. If n is given, so we have to just need 2 more values, a and d. And in this problem, a is already given, d is not given. So first of all, to use this formula, we have to calculate d. and where we will calculate d by this formula S14 equal to 1050. So we know the sum of n terms Sn can be written by this formula n by 2, 2a plus n minus 1 into d. Put the values of Sn in place of Sn. So here we have S14, that is value of n is 14 and value of a equal to 10. So put the values of known terms here, known numbers here. So Sn is 1050, n is 14, 14 by 2 into 14 by 2 into 2a. 2a means 2 into 10, so it will become 20, and n is 14, so 14 minus 1, that is 13, and d. So this will be 1050 equal to 14 by 2, that is 7. So 1050 equal to 7 into 20 plus 13 d. Okay, so next we have to solve this equation to get the value of d. From this equation we can write 1050 equal to 7 into 20, 140 equal to plus 7 into 13, so it will be 91d, and from this we have to calculate d. So 91d equal to 1050 minus 140, so it will be 0, 5 minus 4 equal to 1, and 1 minus 0, so here 9, 9 minus 1, that is 10 minus 1, that is 9. Okay, so it will be 910. So value of d will be 910 divided by 91, that is 10. So we got value of d equal to 10. We already know the value of a equal to 10, and we want to calculate 20th term, a20. Okay, so a20 will be put the value of a here, value of a is 10, plus n minus 1 will be 20 minus 1, that is 19, into value of d is 10. So this will be 10 plus 190, that is 200. So this is our final answer, 200. A20 equal to 200. So for this question we have first calculated d by using formula Sn, and then we have put all the variables here, a, n and d, and calculated an equal to 200. This is if mth term of an AP is 1 by n and nth term of AP is 1 by m, so that the sum of mn terms is 1 by 2, mn plus 1. Okay, so here we have two terms already given, and that term is mth term and nth term. So by our general term formula we can write the terms here. am is given, and that is equal to 1 by n. Suppose the sequence, this sequence AP have first term that is a1 equal to a, and the common difference, that is d, equal to d. Okay, so we have common difference here d, and first term as a, and mth term is 1 by n. So we can use the general formula of AP. So that general formula of calculating any term was here it is am, so it will be a plus m minus 1 into d equal to 1 by n. Suppose this is equation 1, and we have one more condition, nth term of this sequence is 1 by m, that is an equal to 1 by m. We can write the general formula of an, that is a plus n minus 1 into d equal to 1 by m, equation 2. Here we have two unknowns or two variables a and d. We don't know the values of a and d. M is a constant already given in the problem, n is a constant already given in the problem. So we have two unknowns a and d, and we want, if we calculate this a and d, we can use the formula of Smn and we can show that the sum is 1 by 2 mn plus 1. So first of all, we have two variables and two equations, so solve these two equations and calculate the values of a and d, and then put these values of a and d in some formula. Okay, so I am going to solve these two equations. So here equation 2 minus equation 1, I am subtracting equation 2 in equation 1 in equation 2. So we will get equation 2 is this and equation 1 is this. So it will be like left term will be minus in left term, left side, and right term will be subtracted in right side. So here a plus n minus 1 into d we will subtracted in a plus m minus 1 into d, or we will subtract this term in this term. Okay, so this will be minus a minus m minus 1 into d equal to, here in right side we have 1 by m, here we have 1 by n, so the difference of these two numbers 1 by m minus 1 by n, so it will be 1 by m minus 1 by n. Positive a and negative a will get cancelled out. We will get n minus 1 minus, if we take d as common, so here it will be n minus 1, here it will be minus m plus 1 into d equal to 1 by m minus 1 by n. Okay, so this plus 1 and minus 1 will get cancelled out. We will get n minus m into d. If we take LCM as mn, so in numerator we will get n minus m. So we can see here in numerator we have n minus n and n minus m. So this will get cancelled out and we will get the value of d as 1 upon mn. So we got our one variable d as 1 by mn and another variable we have a. So from this we have to calculate a. So put either this value of d either in equation 1 or in equation 2. So I am just putting the value of d in equation 1. So it will be a plus m minus 1 into d. d is equal to 1 upon mn and this equal to 1 by n. So it will be equal to 1 by n. Now it will be a plus multiply this 1 upon m mn in this m minus 1, so it will be a plus m divided by mn minus 1 upon mn equal to 1 upon n. So this m and m will get cancelled. A plus 1 by n minus 1 upon mn equal to 1 upon n. This one will get cancelled out. A equal to 1 upon mn. So from these two equations we have calculated value of d as 1 upon mn and value of a as 1 upon mn. Okay, same, and we want to calculate the sum of mn terms, and that sum is equal to 1 by 2 mn plus 1, so that we have to show. So we have calculated a and d. Now we have to apply the formula of Sn. So we know the sum of n terms of an AP can be given by the formula Sn equal to n by 2a plus n minus 1 into d. So just use the formula Sn equal to n by 2a plus n minus 1 into d. Put the value of a as 1 upon mn and value of d as 1 upon mn here. So we will get Sn, we don't have to calculate Sn, we have to calculate mn terms. So in place of n it will be Smn, and we have to show this value of Smn is equal to 1 by 2 mn plus 1. So Smn will be equal to, in place of n we have to put mn. So here it will be mn by 2 and here it will be 2a. Value of a was 1 upon mn, so write 1 upon mn in place of a plus n minus 1, and in place of d put 1 upon mn. Solve this equation. Smn will become mn by 2 divided by 2 by mn. Here we will get 2 by mn plus, here multiply this 1 upon mn, sorry I have written here n, but we want to calculate the sum of mn terms. So in place of n we have to write mn. So multiply these two terms, it will be 1 minus 1 upon mn. Okay, so here we have 2 by mn and here we have minus 1 by mn. So 1 by mn will remain, so it will become mn by 2 into 1 upon mn plus 1. Solve this, so it will be mn by 2 into, take mn as LCM, so here it will be 1 plus mn by mn. So in numerator and denominator we have mn, so it will be get cancel out, and we will get finally Smn equal to 1 plus mn by 2, and we have to show this Smn is equal to 1 by 2 mn plus 1. Here we got 1 plus mn by 2, that is same. So this was the problem.